But just about a week ago, that was revoked again. So now personal drones, hobbyists can fly their equipment without requiring them to register with the Department of Transportation or the Federal Aviation Administration. So the next steps for drones in India, at least what we think, is that we definitely need some concrete regulations for the use of drones in India, both importing drones, if we already have them, and how do we fly them in India, right? And the corollary to that is how do we define what is commercial versus non-commercial? How do we do R&D on drones, for example? How do we do corporate required flying versus personal flying or flying for fun? And of course, flying and operating guidelines. Like, for example, like I said, if you have a campus, will it be okay to fly that inside the campus? Will it be okay to even power up a drone in our lab? Because that still emits radio frequency, right? So are we violating some guidelines because of that? So we definitely need to move forward in this space and work with the government, or push the government, in fact, to get some of these questions sorted out and get answers to many of these. And I think we have a lot of companies that are doing really great work when it comes to drones, manufacturing indigenous drones, coming up with use cases, working with the government and many of the regulatory bodies, and also actually putting them to work to a certain extent, right? So I gave example of the Bangalore police using them, and also like the Gujarat government has been talking about it a lot. But largely, we are still looking at this as a nascent technology, and think this as a new thing, right? So we need to evolve, get this to industrial grade commercial use, and put the drones to work. And we can. We have a lot of use cases and requirements that can be met by many of these drones that we already have in the market and we are building in India. And of course, when we do that, we need to do it safely and securely. So that comes to almost the end of my presentation. I have a small video that I like to show you guys.
The dream of flight, from the Wright brothers to Sputnik, to the interplanetary mission known as New Horizons. The human drive to explore our world from above has driven the continual innovation in the technology of flight, both manned and unmanned. Already, UAVs have made the leap from the realm of science fiction to being an everyday tool of the trade in a diverse array of vital industries. From agriculture to construction to infrastructure inspection, even entertainment. And thanks to continuing advances in the effectiveness of onboard compute, camera and sensor capabilities, and automated flight control, the era of true autonomous flight draws closer by the day. Commercial-grade, multi-rotor platforms like the Intel Falcon 8 Plus offer the robust reliability, safety, and maneuverability required by even the toughest assignments, while fixed-wing solutions provide a highly productive means to capture detailed data along large-scale linear structures such as pipelines, railroads, and telephone lines. And soon, the development of entirely new hybrid form factors will combine the best features of multi-rotor with the productivity and longer flight capacity of fixed-wing UAVs in a single unit that can do it all. Most exciting of all, the coming integration into UAVs of other key technologies driving the data revolution, from 5G to predictive analytics, machine learning, and more. All of which positions the UAV industry as the place where the next wave of innovation is taking flight. So, if you want to get a glimpse of the future, all you really need to do is look up.
All right, that's it. Thank you. Any questions? It's the computing platform. So you need separate battery and sensors, that whatever you want to attach to it. Yes. Yeah.
Subject like we use solar equipments and for drones and all. I mean, most of the equipments which you showed is consist of batteries and some sort of automated rechargeable, right? So do the solar powers also, it runs through solar? That's what.
Not today, at least in the product portfolio that we have, primarily because the power requirement are more than what we can get, for instance, from solar, right? So we are talking about, for example, if you're talking about a multi-rotor drone, does not have enough real estate to put enough solar panels there to generate the power that it needs for the duration of its operation, for example. It could be something that there is research in the future, but not of today. All right, thank you.
Of the drones and all. Next up is Vipul Singh. He's the director and co-founder of Aarav Unmanned System. He has a bachelor's degree in aerospace engineering from Amity Institute of Aerospace Engineering Research and Studies. We welcome you, Vipul.
I guess that was a very good presentation by Sumanth, and he has covered the details of drones and what are the varieties of drones right now in the practical uses. So I'll be focusing more on certain applications and more about where and how they are solving these problem statements, especially what we as a company are targeting. So we as a company, it's a very young startup, three and a half years old, started back from the campus of IIT Kanpur. And we are basically focusing only on the commercial applications. So our drones as well as the surrounding softwares and technologies which we are putting up together is all focused on these particular three large problem statements. The problem statements surrounding the topography mapping, precision agriculture, and industrial inspections. So as a company, we are developing both drone as a hardware as well as the ecosystem around it, which includes the analytics and processing capabilities so that we can solve the entire problem from end to end. Drones, so they won't have to put different things together to get their problem solved. They can just come to one stop, get the drone as well as the data and get the analytics as per their use case requirement. As a company, we have been able to fortunately develop both the fixed wing and as well as the multi-rotor platform. One of the platform Insight is kept here. So I haven't brought the fixed wing to the event. So just to cover very briefly that where do we stand as a company in the industry right now. So we have been recognized by various platforms for our innovation and as well as technical contribution in the domestic industry. So we are recognized by Startup India program. We have been top 10 of Qualcomm Design India Challenge. We have been the top 10 emerging tech startups listed by Times of India, as well as into the Tech 30, which is a very known challenge in India, which happens every year. So talking about the problem statement, this is where I'll be more focusing on the problem and as well as the how drones are solving these problems. So I'll not go too much into technicalities of the drone. Many of us are aware as well as a lot of information is available on the internet as well. So there are three problem statements which we foresee are going to be the largest ones in terms of market as well as the regular use of drones in the coming at least 5 years. So one of the application is the GIS industry, where we are looking forward to update the maps at very high resolution and very high accuracy, wherein both India as well as global countries have been struggling to update the data at very high rates. This is where in last couple of years, most of the drone uses have been taking place. Even there has been a sequential development of consumer grade drones towards these applications. So what happens when we talk about the GIS industry? GIS industry basically covers all our mapping as well as topography data collection, which means the information about the geometry of the land, the distribution of various, let's say, facilities, as well as measurements. So what are the industries which are looking for GIS survey on regular basis? So when we talk about, let's say, GIS survey to be done, it's road projects, mining, our railway corridor developments. We see a lot of engineers collecting data throughout the day in the cities where they're carrying total stations and DGPS, a tripod kind of equipment all around the path and the terrain and then collecting some coordinates. So what we deal with today is moreover a 2D representation of our maps, what we see even on the Google map. We don't have 3D maps available for most of the locations in India. And that's where drones are changing the game. They are able to cut down the time, increase the efficiency, as well as deliver much more high accurate data and the resolution, which is beyond the capability of existing techniques. Now, same is the case in the industrial inspections. So there are particular industries in which there are locations which are hard to reach. There are critical applications where there are safety concerns, as well as the flexibility and the detail which is required is not available with the existing methods. These are where the drones are being used with a combination of particular sensors to collect these data on an autonomous basis, so that the industry can take a very good, let's say, measurement-driven decisions rather than opinion-driven decisions. So most of our decisions in the industry today are based on opinions. People or an individual will go analyze the location and then give it its own personal opinion, which is again based on a person's experience, much more like a decade ago doctor used to be. Without any X-ray and MRI reports, they used to just give the opinion based on their own analysis. So that's how our industries are working, most of the developing nations. So drone enables us to get measurable data out of the sensors as well as the way that they are collecting data. Same is the case for the precision agriculture. Though Western countries have adopted drones for their agriculture activities on a large scale, wherein in countries like India is still lagging behind in adopting most of the very trivial kind of solutions. Forget about the drones. Drones are still very futuristic for the agriculture industry in India. So we still are not able to quantify or avoid any failures in our crop based on a real-time analysis. What we get to know even with the most advanced satellites that India has been launching in last 5 years is the statistics about what has happened in the season or what is predicted to happen. So the farmer doesn't, in India, does not have any tool to avoid anything which is happening, to identify the development of a disease or identify what is to be done to basically enhance the yield or save his expenditures. This is where, again, drones are enabling very real-time data available from very specific multispectral sensors, which is, again, enabling these farmers to take a very realistic approach towards their farming and improvise their inputs as well as improve their yield. So just to put in a nutshell that why there is a whole lot of buzz about the drone, especially in the commercial applications. So whatever we have been doing, either in the industry of GIS as well as inspection or precision agriculture, there have been various methods of collecting this data. One of the method used to be satellite imagery, what we see in our Google map. So its resolution is less. When we want to really use it for any commercial applications, the economics doesn't work out for small areas. By small areas, I mean few hectares. So let's say someone wants to build a dam or wants to build a road of a few hundred kilometers or want to build a railway stretch, or let's say just a construction site for a building. You don't have enough or accurate data from the satellite or economically viable wherein you can take measurement driven or let's say statistical decision over it. And it's very expensive and the update rates are very poor. So if you want to know that what is your progress today and what's the progress after 1 week, you don't have enough data available from at least generally available satellite data. You would have to pass through a lot of regulatory hurdles to acquire such inputs. Now, the other layer of information which is available or the method which is available is through manned aircrafts, where you put certain sensors, fly the drone over that, the aircraft over that area, collect the data, process it, and get the very high resolution data. Now, the operational flexibility is very poor. These kind of aircrafts are available with only a couple of entities. So the flexibility of operating such equipments is really very tough or let's say difficult. And the cost of acquisition of data is really very high. So what has drone industry, how the drone industry has emerged and what lies beyond it? So what is next? I mean, let's say if we don't have drone, what do we do today? We send the civil engineers out there in the field or people in the field with certain type of equipments, handheld equipments to collect the data. Now that data can be also collected precisely when the person knows how to operate that equipment, analyze the data. Second, the area where you want to collect the data is reachable. So that's where one of the major advantage where the drones are able to deliver. First of all, they're flying at very low altitude. The same sensors which were earlier being put on the satellites and aircrafts have miniaturized. So gyroscopes which used to be of few thousands of dollars are now a couple of dollars. Miniaturized to a small, let's say a millimeter kind of size, which used to be a big box, where in lunchbox kind of size sensors were available for the aircraft. So that's how the drone has been able to airlift. So we have to list, basically categorize the drone into two parts. One is the vehicle itself and the payload. So the payload has been into the picture from a very long time. From last 1 decade, even the small handheld drones have been used for the military applications. It's just the price of the sensors have enabled for the consumer as well as the commercial applications, as well as most of the applications have emerged because of the miniaturization and cost effectiveness of the payloads. So that's where drones are bridging the gap when we really need to collect data for small area like few acres to a few hundred square kilometers. Drones are more efficient. They are autonomous, hence they are autonomous, so you don't need, you don't have any issues with the error which are being induced by the manual methods. They are flexible enough to be operated in almost very large domain of terrains as well as the environmental conditions. So they can bear environmental conditions which a normal human being cannot bear, and they can reach out to terrain where it's very difficult to send a person and collect the data. And because of advanced image processing techniques, we are able to generate very high resolution and very accurate outputs, which again is not just giving us opinion about the area, but also giving us measurable outputs, which is not just enabling again the engineering decisions, but also the management decisions. So there are a lot of new techniques coming out every day in the market to generate statistics over the data, which again is helping the large industries to take smart decisions, just what IoT devices have enabled the industries to take care of. So in a nutshell, if we put it for the surveying industry, the drones have delivered very high accessibility, which was a challenge. Almost 10 times faster rate of data collection, million times richer data. Moreover, the most important part is the realistic 3D data which we are able to get today. And zero ground effort, so a person just have to remove, take out the drone from a box and plan the flight path on a laptop, which requires 2 days training. And then let the drone do the work and collect the data, and then you can take your decisions over data. In the industries, what we need is that quick data, accurate data, insights into the areas where a person cannot reach. Whereas in the agriculture, we need very realistic data which can be quantified and some corrective measures can be taken. So as a company, in our portfolio, we have two platforms. One is a fixed wing, which flies for around 50 minutes. It's fully autonomous, doesn't require any piloting. It can collect both multispectral as well as the RGB data, weighs only 1600 grams, so can be hand launched and belly landed, doesn't require any special equipment to be operated. With the very accurate positioning sensor, the data which we get out of these platforms are 2 to 3 centimeter level measurement, delivers 2 to 3 centimeter level of measurement accuracy. So they are very different in terms of the way they've covered the trajectory and the way they collect the data. It's very different from the general drones which we see around in the events and flying and collecting imagery and videos. Same goes for the multi-rotor, which is named at an Insight. So it flies for around 40 minutes with different varieties of payload. The flight time varies between 40 to 30 minutes. It collects data both in the RGB spectrum, multispectral, as well as the thermal spectrum. It weighs around 4,200 grams, range is around 3 to 5 kilometers from the radio line of sight, and delivers a similar kind of 3 to 5 centimeter level of accuracy. So when we talk about the solutions and applications in these particular sectors, there are certain use cases which are emerging really very well in the domestic industries as well as the international market. So mining is the one use case where regular data collection is a necessity, both in terms of regulatory as well as smart decisions and operations of the mine. Very recently, the mining ministry in India itself has issued a recommendation letter to all of the mining companies to start utilizing drones for their regular work, wherein the data accumulated by the drone will be used by the softwares to plan the activity, as well as the same data can be shared with the regulatory bodies so that any kind of infringement of law or environmental affairs can be very well analyzed and then penalized as well. Urban planning, so there are initiatives going on in India where drones will be used for land records and land records management, commercial tax assessment, as well as planning of the areas, new towns, and as well as 3D city initiative, which in Digital India program has taken place. In terms of corridor, what we have observed practically with our clients, the timeline which earlier manual methods used to take for, let's say, survey 100-kilometer stretch of a road was around 6 months, wherein generally available drones have been able to cut down that time to around 25 days, which is like 1/5 of the time, and deliver million times more richer data. So that's how, if we talk about lakhs of kilometers of road to be built in a year, this is what the ministry at least claims. The most of the hurdles comes when practically we need to collect data on the ground. People spend years to actually analyze the area and quantify that how much effort is going to be there, and even put a fund to it. So that's where drones are able to collect those data, where you can again do the analysis of everything, including that how much trees are to be cut, how much land is to be removed, how much land is to be filled, how many lands are to be acquired, what are the encroachments. So there are some practical cases which I'll be showing very soon. We have been working even with the irrigation department, where drone data has enabled hundreds of square kilometer area to be surveyed within a period of a month. And the irrigation department has been able to identify all the possible solutions using this data. I've already covered the plantations and farmlands. There are practical use cases in India where, based on the data collected by the drones, people have been able to decide their pesticide, fertilizer, and irrigation inputs to the farms. So this is one of the video which shows the workflow, that how actually, just a second. So I've been talking a lot about the application. Actually, how it looks and how it works is very necessary to be understood. So this is a typical video which shows about our workflow, that how our technology works, and what exactly it delivers. So the first part of the workflow is always to collect the data. This is where the intelligence on the drone plays a role. So you have to basically use a user interface and integrate it with any digital map. Can be a Google, Bing map, or your own digital map. You just need to plan the area. Let's say you select the area of your interest. The algorithm, based on the kind of data you want to collect and the use case, will design the path for the drone. Fix the envelope, how high it can go and how far it can go. You just need to launch it. Once the drone is launched, it is in fully autonomous mode. It goes and basically covers that path which was given by the algorithm. During that course of flight, it will keep collecting the images at a precision of, let's say, 2 centimeters. So each and every image has to be captured at a very precise location. If it misses an image or it deviates by a centimeter, the accuracy is lost. So that is where the intelligence as well as the right hardware and software combination plays a role. Once it finishes the task, it lands. You can choose the position of your landing. In this case, it is the same location from where it was launched. So once the drone lands, you need to retrieve the data, process it, and this is what you get: a very realistic, real textured and accurate 3D model. So if we see at the right-hand side bottom corner, each and every point which is visible is having its individual lat long and elevation value. So you can use this data to compute anything: the area, the volume, the depth, classify the data into different layers, that how much greenery, how much roads, how many railways, houses, poles. It's a use case of a mine, iron ore mine. So earlier, people used to spend around 6 days to cover this mine and stop the operation. With the drone, the same task was finished within an hour without stopping any operation. And the precision, you can see how rich the data is. This is a very, very interesting use case, and we were fortunate to be the part of this project. So that temple which we saw in this video was Mahakal temple in Ujjain. So we collaborated with a couple of universities out of Netherlands, Singapore, India, and as well as the MITI, Ministry of Telecommunication, to do this project, wherein the entire Ujjain city during the Kumbh Mela was mapped within a period of 3 days, around 6 square kilometers. And the authorities used this 3D model to devise their plan for crowd movement and logistics movement, and also plan the security measures, that which road to be used for what movement and what kind of emergency exits, where to place what kind of utilities, for example, the first aid, the water, as well as, let's say, there is a kund around that temple. So that was to be filled during that period so that people can take bath. So using this data, they even computed the water volume which is required to fill that kund. And the simulation was run that how much evaporation will happen every day. So each day, how much refilling has to be done. So these kind of statistics were enabled by this data. So that's how drones are basically driving the decision in the industry. So these are all examples of India. So let's say I want to calculate, I have a road stretch of 10 kilometers, which was again done within 2 hours. So I need to calculate, if I want to widen this road, how much is the farmland which I need to acquire, who is the owner of that farmland, there are a lot of conflicts in the record which the government has and what exists on the ground. I can always solve these conflicts with this kind of data. I can calculate the trees to be cut, and we can very clearly specify that how much rework is to be done to re-establish that greenery. So our environmental affairs are managed, and there is no discrepancy between two people taking the decision, because the data is as it is on the ground. So within a second, I can calculate the volume of the ore there. Now, how it helps? How it helps in this way that, let's say I am a mining industry, and I have been extracting ores every day, thousands of tons. I need to make sure that my production is meeting my demand requirement, or let's say I don't overstock. Because if it is overstock, then I have to deal with the maintenance issue. If it rains, it will wash out. I'll be facing theft issues. If I have too much stock, people will steal it in the night. So how to manage that speed? If you keep collecting the data with the drone on regular interval, let's say every day by spending 1 hour on the field, you know that what is existing and what is the delta every day. And you can keep maintaining that delta and even devise your excavation plan and issue it to your field engineers so that the balance can be maintained. Same way, the regulatory body who has given the contract to any excavation agency can track the revenue. So if I extract X meter cubes of ore, I cannot fool the authority that I have given X minus or X plus meter cubes.